Hi everyone, welcome to Mega's tutorial. In today's class, we are going to study about the second case and the third case of the motion of a charged particle in a uniform magnetic field. ಹಿಂದಿನ ವಿಡಿಯೋದೊಳಗೆ ನಾವು ಇದ್ರ ಕೇಸ್ 1 ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ. ಇವತ್ತು ವಿಡಿಯೋದಲ್ಲಿ ಕೇಸ್ 2 ಮತ್ತು ಕೇಸ್ 3 ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಕೇಸ್ 2 ನಲ್ಲಿ ಏನು ಬರುತ್ತಂದ್ರೆ ವೆನ್ ದ ಚಾರ್ಜ್ಡ್ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ಸ್ ಪ್ಯಾರಲಲ್ ಅಂದರೆ ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಡಿಗ್ರಿ ಆಗಿರುತ್ತೆ. ಐದರ್ ಆಂಟಿ ಪ್ಯಾರಲಲ್ ಮೀನ್ಸ್ ದ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು 180 degree. What happens when the charged particle moves parallel or anti-parallel to the magnetic field? Then it does not experience any force. Okay. Since the value of theta is equal to 0 degree and theta is equal to 180 degree between V and B, therefore the path of the particle, it becomes a straight line. Okay. Coming to the third case, this is when the charged particle, it is neither having the parallel motion or the anti-parallel motion. That is, theta value is not equal to 90 degree, 0 degree, or it is neither equal to 180 degree. ದಾಗ ಏನಾಗುತ್ತಂತಂದ್ರೆ the charged particle Q, it follows a helical path. First it follows a circular motion, then it follows a helical path. Okay, on the x-axis we are having the magnetic field, this is the y-axis and this will be the z-axis, and these are the three cases for motion of a charged particle in a uniform magnetic field. Motion in combined electric and magnetic fields, or we also call it as the velocity selector. Velocity selector antandrenu, it is a device used to select the charged particles of a particular velocity out of the beam of charged particles having different values. Okay, that is called as the velocity selector. Here we are considering the charge plus q. Here, say this is a charge q, it is having a velocity of v. In presence of both the electric field and the magnetic field, then the field experienced a force, it is given by F bar is equal to Fe bar plus Fb bar. Okay? This is the force experienced by the charged particle having electric field and the magnetic field. It is used, this velocity selector is used to measure, the E by M ratio. This is one of the uses of the velocity selector. It is also used in the mass spectrograph. Okay. Next, it is also used to separate the charged particles. It is also called as velocity selector or velocity filter, because it filters out the particles of a particular velocity. That is why it's called as a velocity selector. Okay. Cyclotron, it is a machine used to accelerate the charged particles or the ions to higher energies. It was invented by the Lorentz and Livingston. ಈಗ ನಿಮ್ಮ ಆನ್ಯುವಲ್ ಎಕ್ಸಾಮ್ನಾಗ ಸೈಕ್ಲೋಟ್ರಾನ್ ಬಗ್ಗೆ ಇದನ್ನು 5 ಮಾರ್ಕ್ಸಿಗೆ ಕೇಳ್ತಾರೆ. ಅಲ್ಲಿ ಏನು ಮಾಡ್ಬೇಕು ನೀವು ಅಂತಂದರೆ ಫಸ್ಟಿಗೆ ಡಯಾಗ್ರಾಮ್ ಹಾಕಬೇಕು. ಡಯಾಗ್ರಾಮ್ ಹಾಕಿ ಸೈಕ್ಲೋಟ್ರಾನ್ ಅಂದರೆ ಏನು ಅಂತ ಬರೀಬೇಕು. Cyclotron is nothing but a machine to accelerate charged particles or ions to higher energies. Then you have to write the principle of the cyclotron. So what is the principle of cyclotron? It states that the principle of the cyclotron is nothing but the frequency of revolution of the charged particle in this magnetic field. It is independent of the speed or energy or the radius of its orbit. This is nothing but the principle of cyclotron. Then you have to write the construction. What is the construction? Construction alli ಏನು ಬರಿಬೇಕಂತಂದ್ರೆ, in the construction you have to write that a source which contains positive ions or positively charged particle, it is placed at the center P. The particle moves inside the semicircular disc metal containers. Iveru ಏನು D shaped ಅದವಲ್ಲ, we call them as Ds. DEES. semicircular shaped D1 and D2. These are called as Ds. The electric and magnetic fields are applied here. Both will be perpendicular to each other. A high frequency alternating voltage is applied by the oscillator to these Ds, which produces electric field between the Ds. Between the Ds, the electric field will be produced. This whole assembly, this whole setup is evacuated in to minimize collisions between the ions and the air molecules. Next, ನೀವು ಇದರದ್ದು ವರ್ಕಿಂಗ್ ಬರೀಬೇಕು. ವರ್ಕಿಂಗ್ ಓಕೆ, ವರ್ಕಿಂಗ್ ಅಂತಂದ್ರೆ ಏನು ಬರೀಬೇಕಂತಂದ್ರೆ ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಪಾಸಿಟಿವ್, ದ ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್ ಪಾರ್ಟಿಕಲ್ಸ್, ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ protons, these are released at the center P. The particle is accelerated by the electric field across the gap here. They move in the semicircular path in one of the D's, semicircular path in one of the D's, D1 and D2, and they arrive at the gap. Then they arrive at the gap between the D's in the time interval T/2, where T antandre time period of revolution. Then the phase of the oscillator supply is adjusted such that the positive ions arriving at the edge of the D1 and D2 is at a lower potential, and the electric field across the gap accelerates the ions. Okay, now inside this metal box, the D's, that is the particle is not acted by the electric field. The particle is not acted by the electric field, but the magnetic field acts here. Is the magnetic field, it is represented by B. It acts here, the magnetic field acts here. Then every time the particle moves from one D to another, it is acted upon by the electric field. It is acted upon by the electric field, because here in between these two D's there will be the electric field present here. The direction of this electric field is changed alternately in tune with the circular motion of the particles, so that the particle is always accelerated by the electric field across the gap. Each time the acceleration increases here, then the velocity or the energy of the particle also changes. Finally, the charged particle here, it emerges outside through the exit port with the help of deflection plate. As the energy increases here, the radius of the circular path also increases. So the path is it is in the form of spiral. The time period of revolution, it is given by T is equal to 2 pi m divided by QB, which is nothing but the reciprocal of the velocity of the charged particle, where velocity of the charged particle is given by BQR divided by n. So here R means nothing but the radius of the trajectory at the exit port. Then coming to the uses of the cyclotron, already we have known the first used to accelerate charged particles, to bombard to the nuclei with energetic particles and study resulting nuclear reactions. And it is also used in hospitals to produce radioactive substances, where the radioactive substances produced here, which can be used in the diagnosis and treatment. Lastly, it is used to implant ions into solids. Why do we need to implant ions into solids? It is also used to modify their properties. By implanting the ions into solids, it helps to modify their properties or to synthesize the new materials. This is all about the uses of cyclotron.